So I wanted to start this episode off by explaining that we're going to take, this is a second example of a definite integral using integration by parts. Okay, so I'm going to assign my first function, f of x. Okay, actually we're going to do it the other way. Our first function we're going to use natural log, so f of x is going to equal the natural log of x. Okay, f prime of x equals 1 over x. The reason why I chose the natural log of x instead of x cubed is because this function will get much easier to integrate, at the end. So at the end we're probably going to end up having, we're going to have 1 over x times our original x cubed right here, the integral of x cubed, which will cut out an x. If we did it the other way, it would get a little bit more complicated. So I'm going to assign g of x, g prime of x. So g prime of x is going to equal our x cubed. It's going to be x cubed. When we integrate upwards to get our g of x, like I said earlier, we're going to get x to the fourth divided by 4. Okay, or 1/4 times x to the fourth. Now using that, we are going to get our f of x times g of x. So we're going to get the natural log of x. So f of x times g of x, x to the fourth, 1/4. Okay, minus our integral f prime of x, which is 1 over x. 1 over x, okay, times g of x. G of x is x to the fourth over 4. G of x to the fourth over 4. And notice how nicely these cancel out. This turns into a 3 dx, which makes it much easier for us to take this second integral so we don't have to do integration by parts again. We can just do 1/4 times the natural log of x, okay, times x to the fourth minus, so we're going to have the integral, and I'll just rewrite it over here. We're going to have the integral from x to the third over 4, okay, which is going to give us, when we take this integral, it's going to equal dx is going to equal x to the fourth over 4 times 1 over 4. Okay, so we're going to get 1 over 6, x to the fourth over 16. So we're going to get 1 over 16 times x to the fourth. Okay. Now we want all this evaluated. We can't forget, we need it all evaluated from 1 to e to the 5th power. 1 to e to the 5th power. Okay. So, sorry, move it up a little bit so we can see. Okay, so first off, we're going to evaluate e to the 5 using our fundamental theorem of calculus and subtracting everything evaluated at 1. So we're going to have the 1/4 times the natural log of e to the 5. See how nice it's going to cancel. X to the times x to the fourth. Oh, my God. It's 5 to the e to the 5th to the 4th. Okay, minus 1 over 16 times e to the 4th, e to the 5th to the 4th, because we're plugging in e to the 5. Okay, now all of this subtracted, evaluated at 1. So I'm going to get 1/4 times the natural log of 1, okay, times 1 to the 4th power, minus 1 over 16 times 1 to the 4th power again. Okay. Now let's start simplifying things. So we're going to have the natural log of e to the 5. Okay, so we're going to have 1/4 times Well, that's just 5 because the natural log and the e cancel out. You can just put this exponent up front, so natural log of e is 1. Okay, so we're going to get 5, this simplifies to 5, times e to the 20th power, e to the 20th power. Okay, if it's 5 times, when you raise an exponent to exponent, you multiply them, right? So minus 1 over 16, right, times e to the 20th again, e to the 20th power, right, minus, we're going to have 1 over 4 times the natural log of 1 times 1 to the 4th, which, that just simplifies to 1 over 4 times the natural log of 1 is 0, times 1, all those zeros out, okay, minus, remember, all this negative is going to distribute, minus 1 over 16 times 1, which this just is a 1. Alright, so now we're going to start, we got to start simplifying some more. So we get 5 fourths e to the 20th minus 1 over 16 e to the 20th, right? So plus, we're going to have a plus 1 over 16 at the end here. And since these bases are the same, 5 fourths minus a 1/6 is a 19/6. So 19/6. So I'm 16ths, sorry. Times e to the 20th, right? Plus 1 over 16. And there you have your answer for your definite integral evaluated from 1 to e to the 5th power.